So today, let's get down volume, aka capacity. In math, I usually use the word volume, but it's the same thing, right? So volume is like how much stuff something can hold. So today we're actually going to talk about 5 different things. But I'm only going to use, really, I'm only going to use 3 different equations, but they're all going to be based off the same equation, kind of. So let's start with prisms. Who can tell me what a prism is? What is a prism? Yeah, Owen.
It has like a base.
Okay. It actually has 2 bases. Yep. What else do you know about a prism? Do you know what size the faces are, or what shape the faces are? It's a good guess. Rectangular faces. So they could be squares, but if we say rectangle, we're more likely to be. It includes that. All right, and it's 3-dimensional. So that means it has length, width, and height. All right, and under the same thing, we're also going to look at cylinders. How many bases on a cylinder? There's a top and bottom, right? Think like soup can. 2 bases. Are there any faces? No. So what we'll say is we'll call that a curved lateral area. And it is also 3D. So there's no face. It's kind of like there's an infinite faces, actually. That's why. So you guys know what a cylinder is? It's like curved like a soup can. Okay? Now here's what I want you to envision. Volume is the inside hollow or full for volume. If you want to know how much something can hold, are you imagining that the inside is empty or full? You want to know how much it can hold. How much?
Full.
That'd be full, right? So I want you to imagine this with me. Does everybody know what a 3D printer is?
Yeah.
Okay, additive manufacturing. What's the first thing a 3D printer does if it's going to make, let's say it's going to make a rectangular prism. The first thing it puts on the bottom is a rectangle, right? And how many of those does it do to start? It just makes one little rectangle, right?
And that like builds up.
Yeah, and then what does it build up over and over? Rectangle, rectangle, rectangle. So over and over, rectangle, rectangle, rectangle. It builds it up. So you stack those rectangles all the way up. And that's why the bottom base, if you get the area of that bottom base, what do you have to do to that bottom base to stack them all up? Times the height. So that's why this equation works. So you can imagine like a cylinder. You're going to put that circle, that 3D printer puts one circle down on the bottom, and then what does it do over and over? Circle, 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 times the height. That one base. I also like to think about like Post-it notes. Like a big stack of Post-it notes. You got one Post-it note, and you multiply it by the height, and you get a big stack of Post-it notes, right? That's a prism too. So no matter what the prism is, if it's a triangular prism, imagine it puts down a triangular base, and over and over and over and over and over it puts down triangle bases, that's times the height. That's why this one equation works for everything. Area of the base times the height. Now what gets a little tricky is, what kind of shapes can you have for bases then? For a prism, what kind of base shape could you find that we know how to find? A square. Yeah, what else? A triangle. That'd be a triangular prism. What else did we find the area of so far? Rectangular prism and a trapezoidal prism. We did trapezoids too. Now, we have to talk about cylinders specifically. So, cylinders, we have that same volume equals area of the base times the height. But what shape is the base of a cylinder? What shape is it? A circle. And we haven't done area of a circle yet. I'm choosing to go in a different order. But you probably remember from last year that the area of a circle is pi times the radius squared. Yep, so in this case, the area of this circle would be pi times 5 squared. And then you would just take that whole thing and put it in for area of the base. So that this part of the equation is going to change depending on your figure. All right, and then let's say we had a cylinder here. And let's say it was 5, let's say these are centimeters. Let's say it was 5 centimeters high. We have A equals pi times 5 squared. Let's not do 5 centimeters high because I want you to see that these are two different things. And then multiply by 12. So right here, this is the area of the base. This right here, this is the height. But take that base and multiply up, or add up by the 12, and then we got a full thing. So cylinders and prisms, a base times the height will fill it in, right? If you get that visual of it filling in, you won't have to memorize the equation. When I memorize the equation, I memorize it by what it's doing. All right? Now let's talk about pyramids and cones. And no, we're not talking about Jersey Junction and Egypt, okay? We're talking about the shapes, pyramids and cones. All right? So pyramid is going to have something like a rectangular base or a triangular base, right? And a cone is going to have a circular base. But instead of having 2 bases, how many bases do these have? How many bases do these things have? This one's hard to see. This goes to a point right here. How many bases do those 2 things have? Each. 2 bases? 1 each. So that's a little different, right? Are pyramids going to have triangular faces? Our cone's going to be curvy. And they're both 3-dimensional still. So they have length, width, and height. You can't perfectly draw 3-dimension because you're drawing it on 2-dimensional paper. So some people get a little tricky and they can do stuff. But I want to show you something kind of crazy. What we're about to do is, you know how I have that really old cereal over there and I told you I use it for something? We're going to do a little experiment. So I'm not going to be able to put the experiment on this video, but watch what we do here. Oh, after seeing that, it took 3 of the pyramids to fill the prism. So that means the volume of the pyramid is 1/3 of the area of the base times the height. Another way you can look at it is like this. Right? So when I need to remember this, I remember that filling them up. It took 3, right? So the pyramid or the prism is 1/3. Sorry, the pyramid or the cone is 1/3. Should we test out? We should test out the cone too, right?
Yeah.
Let's test it out. So just remember, it was true for the cone and cylinder. It took 3. So a cone or a cylinder is 1/3 of the prism the cone or the pyramid is 1/3 of the prism or cylinder with the same base and height. So really, to memorize this, all you need to know is this. One equation, kind of. Now, sphere gets a little funky. The sphere, you just kind of, for where we're at, we got to just remember, a sphere is kind of like, technically, there's a central point that is equidistant from all points on the exterior. You guys might like to think of it more as a ball, okay? But if there's a center point and there's a radius equidistant everywhere, no matter where you go, that's a sphere. And the volume of a sphere is 4/3 pi r cubed.
What does it say after 13?
Equidistant. This is.
Oh.
That does look like 13 a little bit, though. But I think you guys know what a sphere is. It's like a ball. What's really cool about all the circle stuff is all you need is a radius. If you got a radius, you got enough. So 4/3 pi r cubed. 3 dimensions, make sure that r is cubed. Because you don't need to write this down yet, but surface area is 4 pi r squared, and these 2 things look really similar, don't they? So good to have this in your notes, and then I focus on the cubed. 3 dimensions, cubed. Cool.